Now I would like to ask our next speaker, Makiko Minami, a senior researcher, National Institute of Maritime, Port and Aviation Technology, Japan. Our next speaker will talk about the development of the comprehensive simulation system for autonomous ships. Makiko, are you there?
Today, I will be talking about development of the comprehensive simulation system for autonomous ships. In this presentation, first I'm going to talk about the background of this work. Then I'm going to talk about the overview of the safety evaluation and how simulation is used to evaluate the safety of autonomous ships. Then I would like to introduce our ongoing development of a comprehensive simulation system for safety evaluation. And finally, I will make a brief summary. In recent years, there has been increasing interest in the automation and unmanned operation of ships, and the development of autonomous ships is being promoted in Japan as well. One of the requirements for autonomous ships is to improve safety. This chart shows the percentage of accidents per course in 2020. And as shown here, about 75% are said to be caused by human factors. And autonomous operation is expected to reduce the accident caused by these factors. On the other hand, the practical application of autonomous ships requires not only technological development, but also acceptance by society. Therefore, it is necessary to prove that autonomous ships are safe. And we are developing safety evaluation methods and the simulation systems necessary for such evaluations. Safety evaluation follows the approach of automated driving systems and incorporates the concept of a scenario-based safety evaluation framework. This framework identifies hazardous scenarios on which to base the evaluation. This is a specific procedure based on ISO 34502. Thus, while user system interaction and cybersecurity are also covered, the study focuses on identifying hazards related to system performance in Task 1. Next, I will explain how to create scenarios required to identify the risks. Scenarios include normal and critical scenarios. First, clarify the scope of the item to be evaluated. Then, normal scenarios are created based on that scope. Note that these scenarios are created assuming the system is running normally. The next step to create a critical scenario. There are three types: maneuvering-derived, system-derived, and emergency response. Maneuvering-derived scenarios are created by extracting difficult maneuvering scenarios from the normal scenarios. System-derived scenarios are those that include system failures or malfunctions. Emergency response scenarios are scenarios in which fallback responses or the like can be evaluated. Then, Global scenarios must cover the full of the item's scenario space, so we use the physical principal scenario-based approach. Physics principal scenario-based approach is to decompose the navigation task into perception, judgment, and control subtasks, and create scenarios for each subtask in response to the corresponding disturbance. Perception disturbance caused by sensors that detected and recognized objects and so on. Traffic disturbance consider geographic conditions, traffic flow, encounter situation, and the behavior of other ships. And ship motion disturbance refers to mechanical disturbance acting on the hull due to weather, sea conditions, loading conditions, and so on. Next, I'll explain the environment in which these scenarios are evaluated. Test platforms include visual and real sea environments. Each test platform must meet respective requirements for accuracy and repeatability. Visual test platform is suitable for executing scenarios that are too dangerous or complex to execute in real sea. FTSS is capable of performing numerous scenarios due to its high computational speed, and SHS can assess human involvement. In real sea test, evaluation can be based on actual system performance. Experimental conditions vary somewhat randomly. Here is how to evaluate a collision avoidance maneuver. The FTSS evaluates normal scenarios. We verify that no collision or near miss have occurred, and then we evaluate the method of collision avoidance. For the evaluation of the method of collision avoidance, first, compliance with rules such as call leg is evaluated. Then we consider evaluation by OZT, which evaluates the margin of the avoidance maneuver, or by an evaluate area diagram based on relative distance and rate of change of the bearing. Then, from the FTSS evaluation, we extracted critical scenarios derived from maneuvering difficulties. The SHS evaluates critical scenarios. An evaluation of the scenarios identified in the FTSS will be conducted by experts in ship handling. In addition, emergency responses such as fallback will also be evaluated. Next, I will explain an overview of the simulation system under development. A comprehensive simulation system is being developed to perform safety evaluations. The SHS has cylinder-shaped screen with a radius of 6.5 meters, as well as a screen for downward view for brushing maneuvers. In this way, the simulator can be switched between a normal ship handling simulator, in which the operator monitors and maneuvers the ship from the bridge, and the function of connecting to an external remote control center and to an automated system. This is an overview of the FTSS. Each simulation module, such as the automated navigation system, natural environment, traffic environment, sensors, and ship motion calculation, is connected to the simulation management module, through FMI as a function mockup unit or dynamic link library. Then it can be plotted on an electric chart display as a time series of various indexes and displayed in a simplified three-dimensional format. This is conclusions. In this work, we decided to use a scenario-based approach similar to automated driving system to ensure the sufficiency of the test scenarios. We developed a TSS which is capable of high-speed simulation because it is necessary to run a large number of scenarios for evaluation. We are also developing full mission ship handling simulator to evaluate human-involved suctions. We will establish safety evaluation method and develop the comprehensive simulation system to support the development of autonomous ships. Thank you.
I see no question on online system, Pigeonhole. Now, can I ask the floor? Is there any question to her? Okay. Well, thank you so much, Minami-san, for your time.
Thank you.
Thank you so much.